On behalf of the Department of Information Technology, Sri Ramakrishna Institute of Technology, I welcome you all to the guest lecture on application security. Let me take the privilege of introducing the resource person of this guest lecture, Ms. Celine George, who has come to share her expertise with the students. Celine George is a experienced cybersecurity manager working in Cognizant, Canada, with over 10 years of experience in the IT industry as a security professional with expertise in ethical hacking, vulnerability assessment, cryptography, penetration testing, static and dynamic application security testing, secure code review, and vulnerability management. To keep up with the advancements in technology, she has completed industry recognized certifications like CISSP from ISC Square, which is considered a gold standard certification in cyber career, certified ethical hacker from EC Council, computer hacking and forensic investigator, ITIL certified lead implementer. She has empowered, trained, and have mentored individuals in application security space. She has received multiple awards, including a national award in cybersecurity as one of the top 20 women influencers in India by Security Today, Security Update, InfoSec Girls, and the Women in Security and Resilience Alliance. She has been nominated for the EC Council Hall of Fame 2021. On the academic front, she was a gold medalist in graduate studies in computer science and engineering from Anna University and a university rank holder in postgraduate studies from VIT. So, let me invite you for the presentation. The session is yours. Thank you.
But instead information security is a terminology that was used across the industry. So information security normally deals with protection of data, which is done benchmarked against the three pillars of cybersecurity, or we call it the CIA triad, where C stands for confidentiality, I for integrity, and A for availability. So confidentiality is a pillar that ensures the data that's transmitted from a source to destination is not revealed as plain text to malicious attackers or to external people or to people that should not actually know the message that is being transmitted from the source to destination. It's usually achieved by hashing or encryption, the terminologies that you would have learned in college already. You should be aware of encryption and hashing. Integrity is a pillar that ensures your message that you transmit from the source to destination is unaltered, which means the receiver or the recipient of the message receives the exact message that's sent by the source or the exact data that's sent by the source and is not tampered by malicious users or attackers. Availability ensures that your infrastructure, your network devices, your servers, your components, or anything that's required for you to access the data that's sent to you is up and running all the time, just to make sure that you receive your data and is accessible anytime you want to have a look at it. So, listed below are the information security domains. We have 8 domains. It is security and risk management. We have asset security. We have security architecture and engineering. So the first 3 are frameworks that deals with security policies and standards for infrastructures, servers, networks, and for any other components. Communications and network security deals with security for your network devices. Say, for example, your routers, your switches, and anything that makes network communication possible. Identity and access management deals with authentication and authorization. And the last, I'll skip security assessment and testing for a moment for a reason. The last 2, the security operations and software development security, deals with forensics and developing secure code in order to have your applications secure. So where does application security really fit in when it comes to the information security domains? Application security fits into the pillar called security assessment and testing. So the vast majority of application security deals with testing, assessments, securing code, trying to validate if applications are properly developed, instead of focusing more on the secure coding practices to keep your application secure, safe, and running. Moving on. So, when it comes to application security, again, there are different domains. So, if you look at the other domains, when it comes to communications and network security or the other pillars of information security, all of these deals with either appliances or components like web servers, your infrastructure, routers, switches, your backend server, and all of it, the security related to all of it. But when it comes to application security, it always deals with your software, the security of your software. But then it's very important for you to understand the different types of software or different types of application, and then fit in the correct standard or the correct guide, correct testing practices, uh, apply the correct testing practices for you to validate the security posture of an application or to develop a secure application. So let's quickly run through the type of applications. We have different types of application like thick lines, web application, mobile application, and standalone application. So most of you should be aware of the different types of application and how it really works. But then I'll quickly touch upon the types of application, and then we'll focus on web applications in particular for this lecture today, and help you with the testing standards, the security standards and policies, and then some hands-on for you to understand the real attacks. So thick lines are software that are installed in one of your machines, say your desktops or your laptop or your servers, but that communicates to a different server, a physical server or a virtual server via a network connection. Thick lines are also called fat clients because most of the processing happens in the client side and very little processing happens at the server side. Web applications are otherwise referred to as thin clients because they again have a client and a server. In the case of web applications, the client is your web browser, and then there is a web server that the browser talks to. But most of the processing happens at the web server or the backend server, which is your database server. It could be a SQL or Oracle or any other kind of database. But most of the processing happens either at your web server or the database server, and for this reason they are called thin clients. And all of you should be aware of mobile applications. We have different types of mobile applications. We have Android, we have iOS, we have hybrid applications, we have native applications, and all of the different kinds of mobile applications, platforms, and frameworks. And finally, we have standalone applications. So what is a standalone application or a desktop application? How does it differ from a thick client application? So thick client is going to have a client and a server. Similarly, a, a thick client is going to have a client and a server, and it is to be installed in one of your systems. Similarly, a standalone application is also a software that's installed on one of your systems, be your desktop, laptop, or a server. But then there's no communication that happens between the installed application and the server, physical or a virtual server. A simple example would be a calculator that is installed in your computer. That is a standalone application. So these are the different types of application. The reason I'm listing out the different types of applications is because we are going to see the standards next. And there are specific standards for each type of application, security standards and policies. And you will have to fit in the correct standards if you're going to validate the posture of an application based on the type of application. Any questions so far?
No, ma'am.
Okay, so we'll continue with the session and then we'll take a Q&A at the end of the session. So moving on to web applications. So what is covered as part of web application security? There are different frameworks, testing methodologies again, some of which I have listed here for you to understand. We have secure software development, we have threat modeling, vulnerability assessment and penetration testing, and secure software development lifecycle. So secure software development is something that aims at writing secure code just to prevent vulnerabilities in your application. So just before we jump into the different methodologies of application security, is very important for you to understand what a vulnerability is, what an attack is, and what a breach is. So vulnerability is a loophole in your application that allows an attacker or a malicious user with a malicious intent to break your application. So, for example, I can say application that does not validate any of the inputs is said to have a vulnerability in their input fields. But an attack and breach is something that an attacker uses. An attacker takes advantage of a vulnerability to exploit your application and pull in details from your application. It could be sensitive information like passwords, or it could be, a denial of service attack kind of thing where the attacker tries to bring the application totally down so it's not available for end users to access. So, breach or an attack results in a consequence for the organization, which can damage its reputation. It can cost a lot for the organization to build the application back up and running. It can cost users because it could reveal sensitive information like username and passwords. So let's get into threat modeling now. So we have discussed about secure software development. The next one is threat modeling. So when it comes to application development, we have different stages. Like we have the requirement analysis or the requirement gathering. Then we have the design, we have coding, we have testing, and finally the production. Threat modeling is an assessment that is done at the design stage. You would have the data flow diagrams that simulates how the application should really look like. So a design is something that's developed even before a code is written. A code is written for an application. So performing a security assessment or validating the posture of an application using the design or the data flow diagrams is referred to as threat modeling. Next one is vulnerability assessment and penetration testing. So vulnerability assessment and penetration testing is usually done after coding. So your application is developed, it's up and running in one of your dev environments or your testing environments, and a security tester would really assess the application to see if there are vulnerabilities. The difference between vulnerability assessment and penetration testing is vulnerability assessment aims to uncover just the vulnerabilities in your application. Say, for example, are the input fields properly protected? Are the cookies in your application properly protected? Are there any loopholes that an attacker can use to bring down the application or pull out confidential information from your application? So these kind of assessments are done when you really perform a vulnerability assessment. Penetration testing goes one step beyond vulnerability assessment, wherein an attacker or a security tester who is trying to validate the posture of your application tries to exploit your application and pull out information from your backend database, or tries to deface the application by making use of a security loophole or a vulnerability that is existing in your application. So penetration testing is a deep dive testing, whereas vulnerability assessment is high level testing. So within vulnerability assessment and penetration testing, we have different types. We have dynamic application security testing, and we also have static application security testing. So dynamic application security testing is a live simulation. It's like how an attacker would really do an attack in real life. You would have your application hosted in either dev, test, or UAT environment, and and the source of your testing would be the URL of the application along with the credentials, or without the credentials. It's up to the security tester to find out the credentials, try and hack and find out the credentials, and then go about the testing. So it is kind of a live simulation, which uh, which is very similar to a real attack. Static application security testing is done with the code base, wherein you're given the complete source code of the application, and we have different tools that try to perform a regular expression matching or a syntax matching, or a secure or a match against a secure coding standard that tries to find out if there are loopholes within your application. Moving on. Okay, so this is not very complicated. It's a very simple thing about applications, but I've put this here for you to understand the different components of web application, because then in the next few slides, we're gonna study in detail about some of the vulnerabilities that affect web applications. So when it comes to web applications, we have different components or appliances, or you can call them physical parts of web application that function together that makes a web application communication possible. We have web browser, we have web server and a database server. So web browser is a front end which an attacker, a malicious user, or a security tester uses to communicate with via web server and database server. So anything that deals with the security of the web browser in itself, the web server or the database server will fall within infrastructure security, wherein the real security posture of the application and the application logic will fall into the application security category. So this is the common terminology that's used. Again, in the industry, we have web server, database server, and web browser. But when it comes to applications, you have a front end and a back end and a middle end. So the front end is usually called the client, and the middle end is usually called the server. For example, if it's a Java application, you would have either HTML pages or JSP pages, which is referred to as your front end. And then you will have your .java files where the actual code is written, which is also called the middle end or application logic. And when it comes to application security, the terminologies differ a little bit. So the .java files are called your server files, and then you have the backend server or the database server, the SQL or Oracle or any other database that you use. Moving on, the standards for application security. Any questions so far? Okay, we'll move on. So the standards for application security, there are different standards that are put together by organizations that help you understand what vulnerabilities are, what application security falls into, what's covered within application security, to help you with your application security testing or for you to write secure code. The most prominent standard is OWASP. It is called Open Web Application Security Project. It is a standard that is devised by a non-profit organization. They improve it every year based on real attacks that happen all over the world. Say, for example, if 90% of the attacks in 2020 are based on SQL injection attacks, then SQL injection would take the first place in OWASP top 10. So similarly, they have controls for secure code, they have controls for mobile, cloud, and they also have application verification standard. Now, it's really important for you to pick the right standard to assess your application. Say, for example, we have OWASP Top 10, which has top 10 vulnerabilities for web application. But then we also have OWASP Top 9, which is a secure coding standard or a static analysis standard. So if you're going to do a dynamic analysis, you will have to pick OWASP Top 10. If you're going to do a static analysis, you will have to pick OWASP Top 9. Similarly, we also have standards, guides, and controls for other types of application. We have OWASP Top 8 for the clients. We also have OWASP Top 10 Mobile, which is a mobile application assessment standard. Similarly, OWASP is coming up with cloud controls and application verification standard, which can help you relate your cloud control, security of your cloud controls, and the policies that should define how a web application should look like. So this is the common standard that is followed across the industry when it comes to application security. But then we also have other standards. We have Web Application Security Consortium that helps with guides, policies, and standards again for web application, but it's less commonly used. We have Microsoft Stride. So the expansion for Stride is spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. So this is a standard that is used for threat modeling. We also have CWE, which is devised by NVD, which is a national vulnerability database. It has weaknesses related to software. So it has top 25 software errors, which you can use to assess the security posture of your web application, your client application, or any type of application. So OWASP Top 10 has 10 common vulnerabilities or prominent security vulnerabilities or attacks that you can use to verify your application against. We are going to discuss two of the vulnerabilities today in this lecture. We'll start with injection. So, what is injection? How does injection happen? So, injection is the number one in the OWASP top 10. So injection, there are different types of injection. We have SQL injection, we have OS injection, LDAP, XPath, Hibernate, we have XML injection, a lot of the types of injection. We are not going to discuss all of this today. We're going to just discuss SQL injection, but it's important for you to understand what injection is. So injection is tricking an application into including unintended commands in the data that's sent either to your interpreter or to your server. So most often how this happens is a user, a security tester, or a malicious user, an attacker, tries to inject special characters into one of your user fields, which is then carried over to the different layers of the application. Right from the browser, it's carried to your web server, and then it reaches the database server if it's a SQL injection, and your Active Directory if it is an LDAP injection, or any other type of backend component based on the type of injection. And the backend component interprets the special characters that are sent by the malicious user and executes a command. That's how injection happen. Now, 10 years ago, SQL injection is the top one vulnerability that leads to most of the breaches across the worldwide. But today it's less common, or people think it's less common, but most breaches today again happen due to SQL injection and XSS vulnerabilities, which are the top one and two in OWASP top 10. So let's get into SQL injection. So when it comes to SQL injection, there are different types of SQL injection. We have error-based SQL injection, we have blind SQL injection, and we also have second-order SQL injection. Let's see what an error-based SQL injection is. So an error-based SQL injection happens when the application does not validate the input that is being passed in one of its input fields, which allows special characters, which is then taken to, like I said, which is then taken to your web server and to your database server. And when it reaches the database server interprets the real meaning of the special characters and executes the query. So it's very easy to identify an error-based SQL injection in a web application. It's just that you'll have to supply a special character in your input field. And if you see an exception stack trace, similar to the one that's given below in the screenshot, you can assure that there is an SQL injection because the application does not handle inputs properly. Either it allows all the special characters to be sent to the database server, or it does not validate the input just to check if it only has alphanumeric, and it does not handle exceptions in a proper way and throws all of the information back to the end user, revealing quite a lot of data, like what the database is, uh, how the query is written, what's the syntax of the query. It gives a lot of information from the backend and the web server, which makes it easy for an attacker to exploit the vulnerability and take advantage of the web application. In worst cases, it could also allow the attacker to pull information from your database server. So this is how it works. An end user tries to inject special characters into, say for example, there's an application that has a login which takes user ID and password. So if it has a SQL injection vulnerability, it's always easy for us to bypass the authentication within an application. Say for example, you have two fields, user ID and password. So the backend query would look similar to what's written here. Select star from users where user ID is equal to a particular value and password is equal to a particular value. So if you have a little bit of understanding about how queries are written, a little bit of programming knowledge, it's very easy for you to write queries on your own and see how the application functions. And when you're sure that the application does not validate special characters to prevent SQL injection, it's very easy to manipulate the query to bypass an authentication logic. So I'll switch screen here for a minute to show you how things work. Can you see my screen okay? Yeah, okay. So just a disclaimer before I give you hands-on, do not try any of these vulnerabilities or attacks over the internet, maybe in your college websites or in Google or any of the websites are available in internet. It's illegal and it's a crime to really try and attack a web application or any sort of application for that matter. So for educational purposes, there are a set of, web applications that are hosted on the internet, and there are pen tested labs which I would give you at the end of the session if you want to really try and hack. But in general, a disclaimer: do not try to attack any of the applications that are available on the internet. So this is an educational site that allows you to test different kind of vulnerabilities like SQL injection, XSS, and all of the top 10 XML injection, cross-site request forgery, and all of it. So I'm just going to show you that this application is vulnerable to SQL injection, and we are trying to bypass the authentication function. So let's get into sign in. I'm trying to send over a special character. So SQL or Oracle or any of the databases for that matter, when queries are written, special characters like single quotes, double quotes, a semicolon or double hyphen, all of these are SQL specific characters or database specific characters which have meaning. Like how you have tags in HTML, you have the script tags, you have the HTML tags, slash, exclamation, and all of it that have different meanings that the browser can intercept and execute. We have characters that match the database interpretation language, which have special meaning. So what I'm trying to do is I'm trying to inject a special character and a random password, try to log in. So this now gives me a error message which says there is an syntax error encountered at line 1 of the query. So what I would interpret from the error message that's given to me is this application is vulnerable to SQL injection. It does not validate the special characters or does not prevent the special characters from entering into the different layers. Say, for example, your web server or your database server. And it does not also handle the exceptions properly because you have a error message that's not tailored, or the error message does not say this username or password does not exist, but it says there's a syntax error, which means it comes from the database or at least from the application logic, which is an exception message that's not handled properly. So what I would try to do is there are other methodologies for you to identify the users of the application. You would at least need to know one particular user or a username to bypass the authentication function. It's a little complex. We're not going to get into all of those stuff for now. I know there is an admin for this application. So what I'm trying to do is I'm trying to bypass the admin authentication logic, and enter into the application without a password. So what I'll do is I'll say admin, close it, and give a double hyphen. So for those of you who are aware of a SQL query or how a SQL query is written, you would very well know that strings are always enclosed or text is always enclosed either in single quotes or double quotes. So I'm trying to do the exact same thing here. So we have a username admin. So the query is going to have username is equal to admin. And I'm trying to close the text or the string. And then I can supply a special character or a special, I mean, set of special characters that have a different meaning in SQL. In our case, a double hyphen refers to a comment. So anything that comes after the username should be treated as a comment by the database layout. So what the query would look like is select this particular user from your users table where your username is admin, and the rest of the query is commented out, which means the password field is not taken into consideration at all when I try to do an authentication. So now what I'm trying to do is I just apply a random password, or it's okay even if you leave it empty, and I try to log in. And I can just bypass the application logic without really giving in a password. I'm trying to log into the application just by making use of a SQL injection vulnerability because the application has not done a proper validation to either filter out the special characters or in some way prevent the interpretation of the meaning of the special characters that's sent to the database. Switching back, we'll come back to the application again when we discuss XSS, but for now, getting back to our presentation. So this is how SQL injection works. This is very basic command which I've tried to explain for you to understand what a SQL injection looks like. But in real world, or when it comes to real application security testing or an attack, it's not going to be very simple. It's not just that we're going to try to bypass an authentication field. In most cases, attackers would try to fetch all of the information from the database, say a list of users along with passwords. There are different complex queries wherein you can use a join or a union or other commands that are available within your database language, which will allow you to fetch information from the database. So this is how millions of records of most organizations are compromised in a breach, where all the usernames or passwords are fetched by the attackers and revealed in the public. Now there are additional measures that can prevent such a breach, like having a password hashed in your database or encrypted in your database gives a layered security approach, wherein even if the passwords are exposed or even if they are compromised, it's not possible to get to the real text or the plain text password for the users. So always when it comes to application security, infrastructure security, server or network security, we would always recommend to have a layered approach wherein you have the first level of defense to filter out special characters or stop special characters from entering your application, and then have additional security measures in your web server. Maybe you have a web application firewall that would again block special characters if for some reason that gets into the application even after the first line of defense. And then you have additional security at the database layer, which would prevent the execution of or prevent the interpretation of special characters that would stop an attack from happening. So let's discuss through some of the basic prevention methods for SQL injection. So we have server-side input validation and parameterized queries. So like I said in the beginning, when it comes to application security terminology, a server-side is the application logic. So in our case, if it's a Java application, it's your .java files, or if it's your .NET application, it's your .cs files. Your .axpx pages, in that case, would be your client side, and your .cs files would be the server side. So what we are trying to do is, we are trying to do a regular expression validation at the server side, which would say your input field should have only alphanumeric and it should not have special characters, so that it does not get executed at the database end. There are different types of validation. We have whitelist and blacklist. It is always preferred to have a whitelist validation because whitelist is the recommended way of validation for preventing SQL injection vulnerabilities. A whitelist would say allow alphabets and numbers, but a blacklist would say do not allow maybe semicolon, colon, exclamatory codes, single quotes, and double quotes. The reason why a blacklist is not recommended is because there are ways to transform these characters or encode these characters, translate these characters to different formats. Say, for example, your single quote could be transferred or could be translated to %3c, which is a URL encoding format, which would again be interpreted by your database. So it's difficult to have a blacklist validation, and it's not recommended to have a blacklist validation, while it's always recommended to have a whitelist validation at your server side. Now you can ask me, why not a validation at the client side but only at the server side? So you can also have a validation at the client side, be it in your JSP pages, your HTML pages, or .axpx pages. But we have something called a proxy tool, which is commonly used in security. These are tools that are in general used to bypass client-side validations. So it's possible for us to intercept the traffic once it's sent out of the application. So once it's sent After your JavaScript functions have finished validation, it's possible to intercept the entire traffic, your GET request or your POST request, along with all of the parameters and perform a tampering there. So once it reaches the server side, there's no way for the attacker, a malicious user, or a security tester or a normal user to capture the traffic and modify the parameters. So for this reason, it's always recommended to have validations at the server side instead of your client side. So this is one level of protection for SQL injection. Similarly, we also recommend to use parameterized queries. Like in the second example, it's a Java code where you have prepared statements. So what happens when prepared statements are used is a database would always treat anything that comes out of a prepared statement query or the parameters that come out of a prepared statement as text. So even if you send a single code or a double code, it's no longer interpreted as a special character by the SQL database. It will be interpreted as a text. So it's not does not get executed as a query. So for this reason, an exploit can be prevented. So it's recommended either to go for a server-side input validation or parameterized queries, or if you want to have a layered security approach, if you want to have additional defense mechanisms, you can use a combination of both. One in your server side, which is your application server side, and at the database end, which is the user parameterized queries. So that's about SQL injection. We are going to discuss one more vulnerability. I'll show you how this really works, and then we'll get into some statistics, some attacks, and then the certifications for cybersecurity. So moving on to cross-site scripting. Cross-site scripting again is another type of injection attack, but then the injection really happens at the browser side and the execution again happens at the browser side. So when it comes to SQL injection, your input, your malicious input is passed from the web browser and it gets executed at the backend server. Wherein for a cross-site scripting attack, your malicious character or your malicious user input is given or supplied at the web browser, and the execution of the malicious input or payload happens at the web browser again. So the source of your malicious input and the destination of your execution is the same, which is your web browser. So cross-site scripting works in a very similar way to SQL injection. The only difference is that for SQL injection, the interpreter is your database, whereas for cross-site scripting, the interpreter is your browser. So for SQL injection, you will have to match the query language, the structured query language, wherein for cross-site scripting, you will have to match the HTML language. So let's get into it. SQL injections are commonly used to bypass user IDs, passwords, authentication, and authorization logic, wherein a cross-site scripting usually tries to pull cookies from your application, which can be used indirectly to bypass authentication. So let me switch screens here again. Back to the same application. So I've logged in as an admin user with an Atro Mutual, which is a banking site. So now what I'm trying to do is I'm trying to exploit a cross-site scripting vulnerability. So for you to exploit a cross-site scripting vulnerability, you will have to match the HTML syntax. So I'll just try and see if a script, so for HTML, it's not going to be a query, it's going to be a tag. So I'm trying to match if I can run a script in one of the input fields. For our example, I'm placing it on the search field. There's a specific reason for placing it on the search field because the payload or the script that you inject should always come back to your browser. Only then it gets executed. If it just gets into your web server or a database server and stays there, it does not get executed. So I'll click on go and we have the script running and we have the alert box, say whatever message we have given in the payload. So you can go through and see at the source, look at the source, or maybe inspect. don't see the value here. But then usually what happens is you will have to match the HTML syntax. Say for example, you have an input tag here along with the text. You will have to match the HTML syntax. So if you have to close a value with a double quote, close it, close the tag, start a new script tag, you will always have to match the HTML syntax for your script to work. Now, this is a very simple example. Normally, security testers would try to run an alert box to see if the application is vulnerable to cross-site scripting. But then in most complex attacks, what happens is they always try to pull in the cookie, which would give your authentication token. So this is a token that can be used indirectly to bypass authentication logic. In a real world example, it's not going to look very simple. The attacker has to um, get hold of the email ID or get hold of the user in some way, trick them into running a script, and then pull the cookie. But just for the testing sake or for validation sake, we normally try to see if the input fields would accept special characters like your um, parenthesis or any other HTML special character, and try to see if we could run a alert box or try to see if we could fetch a cookie just to make sure that it's vulnerable to cross-site scripting. So in this case, we again have different types of cross-site scripting attacks. We have reflected cross-site scripting, we have DOM-based cross-site scripting, and we have stored cross-site scripting. This particular attack that I have simulated or I have shown you, it's a reflected type of cross-site scripting. Let me switch back real quick again. Okay. So let me quickly touch upon the different types of cross-site scripting, like the reflected, persistent. Persistent is stored cross-site scripting, and then we have DOM-based cross-site scripting. So in a reflected cross-site scripting, the payload that you submit or the script or the malicious input that you submit gets through the web browser, reaches your web server, and then comes back to your browser and gets executed. So it does not touch the other layer, like it does not touch the database layer at all. But when it comes to stored cross-site scripting or a persistent cross-site scripting, the script, the malicious payload or the user input that you submit um, gets to the web server and then gets to your database server and gets stored in your table in your database. So a persistent type of cross-site scripting would affect multiple users, I can say. One example would be your registration screen where you supply your first name, your last name, and all of it. And if you try to supply a script tag in your first name or your last name, when you launch the application and where there is a name or address that's displayed on the application, if there is a script tag, it always gets executed. This is for a single user. But if it's a social networking site or if it's an e-commerce site, if one user tries to submit a payload that gets to the database, it gets stored there. And if it's an input that's received by multiple people, it can affect multiple users. And finally, we have DOM-based cross-site scripting. So any of you who have good understanding on HTML, you know what DOM is. It is document object model that comes within your HTML page or within your JavaScript and within your DOM. So in a DOM-based XSS, the payload does not even get into your web server. It gets executed right at your JavaScript functions within your head tag of HTML files. So let's quickly move on to the prevention mechanism for different types of cross-site scripting. So for cross-site scripting, again, a server-side input validation is a must to filter out, either to filter out special characters, or the other way is to encode or translate the special characters into a different form. Say, for example, the left ampersand, the less than symbol that you use for your HTML tags, it can always be converted into ampersand LT, which is HTML encoding format for this particular character. So when it gets translated to a different format, it is no longer interpreted by the browser as a special character. It should be treated as text. It's similar to parameterized queries for SQL injection. And you can also apply a whitelist regular expression kind of validation to filter out special characters just to see if your input has only alphanumeric values. These are some best practices to avoid vulnerabilities within your application, not just SQL injection and cross-site scripting. To avoid vulnerabilities in your general, have basic validation, which checks for data type, which checks for length. Data type refers to strings or numeric values or objects or anything of that sort. Have a null check, have a length check. Similarly, have a server-side input validation or have an escape function that would filter out special characters or translate your special characters to a different format, which is referred to as output encoding. Avoid persistent storage without validation. So make sure your input is always validated before it gets into different layers of your application or different components of your application. Implement proper error handling mechanisms. So even in the worst case, when a script gets executed or the application behaves in a different way, it's always recommended to throw a general error message instead of throwing a detailed exception stack trace, which would reveal the details of your underlying database and web servers. Beware of your hidden input fields. So generally, people think that only the HTML tags that carry input field or the type input that's defined in HTML are malicious. But then even hidden fields could be tampered, like I said, with the use of proxy tools. So it's always required or recommended to have validations for the hidden fields. Implement proper logging mechanisms for you to see if an attack has happened or when an attack happens, what kind of attack has taken place has to be identified only by means of proper logging mechanisms. Use post request instead of get. So when you use a get request, you should be aware that all of your input that's sent to the web server is sent in the browser. So it paves the way for social engineering attacks. So it's always recommended to send your parameters in post instead of get. Use HTTP only. So this is a protocol, a HTTP only or a secure flag that is set on your web server would actually prevent cookies from being revealed to the end user, even if there is a cross-site scripting attack or a cross-site scripting vulnerability in your application. Any questions so far? Okay, so we'll get to the statistics, standards and certifications, and then to Q&A at the end. So here are some quick statistics. 95% of cybersecurity breaches happen due to human error. So human error in the sense it's a software error where the developer fails to write a secure code by mistake or by ignorance, by not knowing that it would actually cause a vulnerability or an exploit. 88% of organizations worldwide experience spear phishing attack. A phishing attack is something that aims to target individuals via email and trick them into a cross-site scripting or a SQL injection attack. So spear phishing is a targeted phishing type of attack, which is commonly used to exploit XSS vulnerabilities. 68% of business leaders feel their cybersecurity risks are increasing. Overall, on an average, only 5% of organizations' folders are protected. So, like I said in the beginning, a layered approach of security is very important. It's not just that you have to protect your web applications, you will have to protect your directories, you have to protect your infrastructure, your servers, and all of it to prevent an attack from happening. So, data breaches exposed 36 billion records in the first half of 2020. So the statement remains very simple for you, like it has just exposed 36 billion records. But then the cost that an organization, um, the consequence of the attack, the cost it has to, put into to prevent such attack from happening or to prevent the reputation damage or to recover from an attack is very huge. 86% of breaches were financially motivated, whereas 10% were motivated by espionage. So espionage is related to competition, like one business, if it competes with other business, and if it wants to take down the application or server of the other business just to make profit, it is referred to as espionage. But most other attacks, about 86%, are financially motivated, which means the hackers would try to attack an application a whole infrastructure or the complete network or of an organization and held it hostage so that the organization has no other way but to pay the hacker a certain amount. It's called a ransom. Pay the hacker to recover the data that's held hostage by the hackers or the attacker. We'll just discuss one particular breach that has happened to Bell. Bell is a service provider, it is an internet service provider in North America, which serves more than 20,000 customers. So, one particular attack revealed customer usernames and passwords of about 20,000 Bell users. Now, you could say it's just the username and password. The user can just go and change in the password. But that does not happen that way. It results in a huge reputation damage for Bell. And then it would also bring down the service for a couple of days, which means the users will not have access to internet across North America, at least for the customers that use Bell. So a detailed investigation was done within Bell to identify what kind of attack it is, and these are the results. So it started with the error-based SQL injection, which revealed what the underlying database is and how the queries are written within the application that talks to the database layer. Now, the SQL injection attack has started out with a error-based SQL injection attack, but then in a detailed investigation, it was revealed that Bell has used outdated frameworks. It has not used whitelisting to validate the input. There was no parameterized query, and it also has got an internal implementation leakage, which means it has thrown detailed error messages and exceptions to end users or the attackers, which actually helped in navigating through the different layers of the application, understand the query that's written at the backend, and then get into a real exploit. Coming towards the end of the session, so this is the last slide that I have for the lecture today. So for those of you who have an aspiration to get into cybersecurity career, these are the top certifications for you. The first one is Certified Ethical Hacker. So if you ask me if it is an application security related certification, it's not. It's a network and application security combined certification. So about 70% of it would be network security and only 30% of it would be application security. But then it is the most common certification within IT industry if you want to get into cybersecurity, even if it's application security. It's very easy to learn. You would have a 4-day course that's given by EC Council. EC Council is a internationally recognized organization that provides certified ethical hacker, CHFA, and similar certifications. So it's not that it's really required for freshers to have certified ethical hacker certification, but then once you grow in your career, say for example you have 1 year of experience in cybersecurity or 2 years of experience in cybersecurity, organizations would always expect you to have CEH. But then if you can do it right at the start of your career, it makes your job search easier because you already have a certified ethical hacker certification. Now we are looking for, if you're looking for specific application security certification, there are certifications that are provided by EC Council like LPT, Licensed Penetration Tester, Advanced Penetration Testing, and we also have certifications that relates to the coding language, be it Java or .NET, if you want to specialize in static analysis for a single language. So the first 5 are basic certifications that are provided by EC Council for you to get into cybersecurity career. And the remaining 4 certifications that I've listed down are advanced certifications, like the CISSP or the CISSP, which is Certified Information System Security Professional provided by ISC Squad, and Certified Information Security Manager provided by ISACA, which is an audit control association, in Information Security Audit Control Association. So once you get into your cybersecurity career, maybe 3 years or 5 years down the line, if you want to get into a management role, if you want to get into a lead position, it's always recommended to have CISSP or CISSP, which are professional certifications. A little complex, it's hard for you to complete. It's very challenging, but then it's worth it. CISSP is recognized worldwide, at least in I mean, in North America, I would say any person who would want to stick into cybersecurity after 3 or 5 years would aspire to complete CISSP. Then we have GWAP and OSCP, which are specific to penetration testing. It's like specialization on application security penetration testing, which are provided by SANS and Offensive Security. These again are complex certifications, but then it's good to go. Now, if you ask me if you can do OSCP right at the beginning of the career, I would say yes. If you want to move abroad and get into penetration testing specifications, I mean, penetration testing specialty, if you want to specialize in penetration testing, it makes your job search very easy if you can complete OSCP at the beginning of your career. So that's all I had for today's session. We are getting into Q&A. I'll stop presenting my screen and over to you for any questions. Okay, so there's one question on the chat. Any certifications based in India as CEH is expensive? CEH is a little expensive, I would say, but other certifications are even more expensive. I don't think there is any other basic certification that is lower in standard when it's compared to CEH. So CEH is the base. CEH is expensive, but it's worth it.
So, as a fresher, is there any alternative to get into cybersecurity?
I would say certification is not mandatory for you if you want to get into a cybersecurity career. It's
Okay,
just that you will have to know the basics of cybersecurity. You can go through OWASP top 10. I can leave it in the chat for you. You can go through
thank
OWASP
you.
top 10. There is a detailed book called Web Application Hackers Handbook, which would give you good understanding of how hacking works, at least for web applications. This is something that you can refer to. And if you want to test your skills, you can always go to this particular website. Do not do it on other websites. Admin is a credential. You also have a normal user. You can use these set of credentials to practice your skills.
Okay.
Now, 5 years ago, the importance was given only for application development. So you would not really see cybersecurity courses in colleges, in graduate programs. But these days, there are a lot of universities that offer 1 year or 2 year course, part-time distance education, and full-time courses for cybersecurity. If you're really passionate about cybersecurity, I would recommend you getting into one of those courses because it can boost up your profile when you get into a job search for cybersecurity.
Thank you. I have completed few labs in Hackabot. I have. I
Okay.
got an idea about the beginning of cybersecurity, but since the courses are expensive, I wanted to ask questions. That's all. Thank you.
Yeah, that's good. So for beginners, you can always look at bug bounty programs. Bug bounty programs are available across the internet. You can search for it for you to practice your hacking skills. There are certain platforms like HackerOne, Crowd, and Pen Tester Lab. But Pen Tester Lab is a paid version, so you can go for the other platforms to test your skills.
Sportsvega Academy.
Yeah, Portsvigger is good for learning. Other questions? Okay, so how many years it would take to complete OSCP? For a beginner, I think at least 2 years. If you have maybe after you get into cybersecurity and once you have 3 or 4 years of experience, you can do it in 6 months or 1 year. But then, as a beginner, if you are really fresh to cybersecurity, you're new to cybersecurity or application security, or just trying to learn the fundamentals of application security, I would say it would take at least 2 years. OSCP is provided by Offensive Security. It's again an expensive certification, but then you will be given a lab kind of setup where you can practice your skills, but it's available only for 90 days. But you cannot really complete OSCP in 90 days. You should have a good understanding of both network and application security and then go for OSCP. Any other question?
Ma'am,
Yeah,
good evening.
good evening.
Ma'am, I don't have the very big question. This is a very small one. Ma'am,
Okay.
when you chose cybersecurity as your main thing or domain, what
Mhm.
were the things which you got yourself more strong or more equipped with, like programming languages or topics or of that kind? Please know, because right now I'm very new to this, so I don't
Mhm.
have an idea where to start with. So
Okay. Okay, so the starting point is OWASP top 10 when it comes to application security or cybersecurity. But then, like you said, it's very important to have basic programming knowledge, at least in one language. So in my case, I was good at Java. It's not that you have to be very good at most programming languages like JSP, HTML, Java, .NET, and all of it. You should have at least basic programming knowledge on one server-side language. It can be Java, it can be .NET, or in the recent times it could also be Python. And you should have a basic understanding of JavaScript and HTML. So if you have a fundamental knowledge or basic understanding of these programming languages, it will be very easy for you to relate to the cybersecurity attacks, how the attacks work, how a syntax manipulation is done to get through an exploit. But it's also possible to get into cybersecurity without having a programming knowledge, but you can only get into dynamic testing. So it'll not be a deep dive testing or deep dive knowledge on application security or cybersecurity. If you want to really get into application security and specialize in application security, make sure you know at least one programming language. So if you know one programming language, it's really easy for you to relate to the syntax of the other languages. Say, for example, request.get parameter is an API that's used in Java for fetching parameters. And the equivalent in .NET would be request.get query string. So it's very easy to compare and identify the equivalent APIs, but you should have knowledge on one programming language at least.
thank you, ma'am.
So once you have a thorough understanding of HTML and one programming language, you can start with OWASP top 10. It's OWASP has the testing guide. It has top 10 all over the internet. It would give you detailed steps, syntax, and all of it, which you can relate to programming language plus some idea on database queries and other stuff would make it easier for you to learn application security. Any other questions? So if there are no other questions, I think we can wrap up the session for today.
I hope there is no more questions from the students end. I have to really thank Celine George for accepting our invitation and spending valuable time with us. I think it's early morning in Canada now. Uh, Thank, thank you for spending your early morning with our students. I also thank my faculty colleagues who are attending this session, and I hope this session would be an eye-opener for students in the domain of cybersecurity. Hopefully, if some students could get into the cybersecurity domain, we would be very happy that this had sparked something in the career of the students. I thank one and all. A special thanks to Celine George. Thank you.
Thank you, Adri, for giving me the opportunity. It's a pleasure to be with you all today in this session. Thank you.
Thank you.